Good day everyone, we're going to take a look at the remaining three theories of chapter 6.1, calculating with percentages. C, D and E, the first two are about calculating percentage increase or in some case a decrease, and the last one is going to talk about so-called multiplication factor and what that really is. But first we're going to take a look at the two examples that are projected right here. The first one is about the price of a pizza which has gone up from 8 euros to 11 euros, so the price increase is 3 euros. And the second one is about the price of a jacket that is going up from 85 euros to 88 euros. That price increase is also 3 euros. So in some way you can say, well, the price of both objects has increased with the same amount, right? 3 euros. But still something is off. I mean, if the price of something expensive like a jacket goes up 3 euros, you won't mind that as much as the price of a pizza, which goes up by 3 euros from 8 to 11, right? We're going to take a look at those two kind of comparisons that you can take a look on from price increases. So as I've already mentioned, both prices increase by the same amount, 3 euros, but relative to the original price, the price of the pizza is now much larger. So you can calculate the increase in percentages in comparison to the old price, and it in some way gives you a better representation of how much a price has really gone up. Let's take a look at how we can do that. So how much is the increase as a percentage? And for this we have a new formula. The increase as a percentage can be calculated by taking the new price minus the old price, divide that by the old price itself, and then afterwards do it times 100%. Don't forget the last part. Very important formula turns this out to be. It's going to be very, very much used. So let's take a look at the increase as a percentage of the pizza. The new price was 11, so 11 minus old, minus 8, divided by 8 times 100% gives us a percentage increase of 37.5%. And the percentage of the shirt is going to be 88 minus 85 divided by 3 times 100% is roughly 3.5%, which turns out to be a lot less. So this new minus old divided by old times 100% is also known as the relative increase. It is the increase that you can calculate in percentage. As you can see, those were quite different from each other, almost by a factor 10. While new minus old, in both cases the answer of that question is going to be 3 euros, is also known as the absolute increase. In this case, just the increase in euros. And this same logic again can be used when we're going to take a look at decreases. You're going to use exactly the same formula for decrease as a percentage. However, you're going to end up with a negative number because new minus old, the new price in this case is lower. So something that is going to be lower than old minus old is going to give you a negative number. So to give us decrease as a percentage, you're going to leave out the minus sign in your final answer. I'm going to take a quick look at an example. Let's say the Nintendo Switch cost 329 euros in 2018. However, the price dropped to 299 euros in 2019. By what percentage had the price of the Switch decreased? I take a look that they say by what percentage. They just asked by how many euros. You could just do 329 minus 299 will be 30 euros, but that's not the question. We're going to take a look at the percentage decrease. So use the formula new minus old divided by old times 100%, with old being 329 and new being 299. This is going to give us, as you can see, approximately minus 9.1%, but as we have discussed, you have to leave out the minus sign. So the percentage decrease is going to be 9.1%. And this minus is only going to show up when you're going to calculate a percentage decrease. If you're going to calculate a percentage increase, this is always going to be positive, so you don't have to take a look at if you have to leave out the minus sign. And the last theory part is all about the so-called multiplication factor. As this theory says, we say that the percentage increase of 18% corresponds to a multiplication factor of 1.18. So really the only thing new that this theory is going to give you is that decimal number that we used to replace the 18% is called the so-called multiplication factor. And you can, as you can see in these boxes, calculate from this multiplication factor back to a percentage as well. In that case, you have to do -1 times 100, right? However, as you can see at the questions you're going to do from theory A, some of them are also about calculating what those multiplication factors. One example is about the transfer of goods in the harbor of Amsterdam, which has increased between 2000 and 2005, and has also increased between 2005 and 2010. If you want to calculate the percentage increase in the period as a whole, you first have to write the increase to that multiplication factor. You have to do that twice, right? And both factors are going to be bigger than 1 because they are both increases. And after that, if you want to know the percentage, you're first going to multiply the both multiplication factors, which gives us a certain new multiplication factor, in this case 1.448. And then you have to calculate that, or really going to calculate that back to that percentage again, right? So you do it -1 times 100. The book isn't really clear about that in this calculation, but you do 1.448 -1 times 100%, and it leaves us with 44.8. Again, if you want to take a look at some more examples, take a look at the other video that I've published about chapter 6.1.